But one thing I want to say is thank you all for the efforts, to the coaches, to the trainers, to the teachers that are here, and especially to you, the students. The work that you're doing is very important. And some of the videos that I'm going to share with you show how the work that you're doing and the work that people before you have done led to greatness in terms of manufacturing and the industry and what you've done. So I wanted to start here with the most impactful development tends to be experiences that we have. So this organization, the work that you do together is truly a remarkable experience, and it will stand with you for the rest of your life. This here is a picture within a factory. It is a clean room, so we have people swapped up. As you can see, they're covered head to toe because particles in semiconductor manufacturing is critical. The numbers that you can see on top are attached to the vehicles that are part of the AMHS, which is an automated material handling system, which distributes those FOUPs of cassettes of wafers to the tools for processing. Okay, so I'm going to take you a little bit through our semiconductor manufacturing process and then show you some applied robotics. So within a factory, the slide's not progressing. There it is. All right. So within a factory, or a fab as we call them, and that's where we do our front end manufacturing. You can see up here in the top area, I'll get my pointer. Okay, in the top area, you can see there are different modules within a factory. We go through photolithography step, we go through etch steps, we go through various cleanup processes, and then we have thermal processes like diffusion, thin film, implants. So there's a multitude. You can see CMPs are chemical mechanical polishing, CVDs are chemical vapor deposition, and then PVDs are physical vapor deposition as we put different layers down on the wafers. And in order to make a wafer, there could be anywhere between 300 or 1,200 process steps within the flow. So it's a quite complex process, and it's extremely sensitive to particles and defects within a factory. Once the wafer is finished processing on the front end, it comes out of the fab, it goes through what we call e-test. That's an electrical test that we do to check the functionality of the wafer. All going well, it will progress then through a bump, a sort, and an assembly test process. So the silicon wafer is like what you see in green. It's typically a 300 millimeter or 200 millimeter or even 150 in some of the older factories, but 300 millimeter wafer. When it goes through the test, you get a wafer map that looks like that. And green stands for good electrical chips. So when they come out, we sort them, and then they move on to the assembly test process, where the backside of the wafer is ground, and then we begin the process of inserting the chip into a package. Once it's packaged, and there are a multitude of packages that we use, it then goes off to my shopping cart at the top, which is our product distribution centers. So I'm going to share with you a video on the product distribution centers, and it looks a little bit like Lego, so you can see how it's applied. Through the entire process, there is a massive amount of data collected, and the data analysis that we do is critical to identify any defects that we do find on the wafers, figure out what layer it went on, and then take the right corrective actions to eliminate them, and even better, to prevent them ever from happening again. So you can see here my little classroom where we have machine learning class. Really, we have to go back and make sure that the data is clean because we want good data coming in to be able to do the analysis on. So, as far as trends in manufacturing, my slide hasn't progressed yet. 1 second. We see the evolution of smart manufacturing and robotics. You can see here across machine vision tools, transportation and handling through robotics, tool control, moving wafers on an end effector in and out of a process chamber requires tool control and robotics. And keep in mind, these are very thin silicon wafers, so if you drop it, it breaks and the show is over. So it's important that we have stable and repeatable robotics moving our wafers through the factory. The environmental control is important. We use PLCs to program, and we use different systems connecting and adding sensors. We use vibration sensors to determine if there's maybe some movement in a robot that makes it jerky and that would put material at risk as well. So we want to be able to predict when trouble is going to happen so that we can prevent it from happening. And then, of course, having secure data in our infrastructure is important as well, because we really want to make data-driven decisions. Okay. So what is important from a manufacturing standpoint? I've listed out some things. Okay, sorry. You're good, Okay, thank you. So what is important from a manufacturing standpoint? And I know a lot of you have been working on a project and you're looking at what are the key components and aspects within your project? What are the key variables? These are some of the variables that we use from a manufacturing standpoint. From a quality standpoint, robotics and repeatable processing provides more accurate processing and less variation, so therefore more accuracy and higher yielding green wafers, as I showed you on the die. From a productivity standpoint, labor is typically a big cost, so the more we can use AGVs and robotics to move the wafers through the factory, that's a cost savings. I have another video coming up on that here, hopefully that'll work for us to show you. And then looking at where we have manual tasks, repeatable tasks that we can set up with intelligence to have it automated as well. So shout out to our software engineers for that work. From a project management standpoint, some of the key things here is the timeline, what milestones do we have, and what objectives are we trying to meet, just like you're trying to do with your project. From a cost saving standpoint, when we invest, we want to make sure we get the return on that investment, and we also want to keep the operating costs low. Cycle time, how long does it take to go through different steps in the process? As I mentioned, there are hundreds of steps, so when you add them all up, how long does it take to run through a process on a particular product? And of course, all the while, safety, our ergonomics, and making sure that our employees are working in a safe environment is critical as well. And that stability, consistent performance is key to high yielding, repeatable results. So this is an example. The next video that I'm going to show you, we'll talk through delivering intelligent solutions using software, using robotics, using automation to create multi-year strategy. It also allows us to establish manufacturing solutions so that we can improve those important metrics that I just showed you. So I'm going to proceed to the next video here. Hopefully this will work. And what I'm going to share with you here is an example of a project that we took on in our Chengdu factory in China, where we have a total solution. You have the front end, the bump, the probe, and the final test assembly. And you'll get a view of the robots that we use to move around the material within the factory. So stay tuned. Sound? No sound. Okay, just give me 1 second, see if we can get sound going here. That worked. Thank you. Switch the display. Switch the display.
Oh, because it's sharing from my laptop.
So you can see the robot moving around the material and see some acronyms. So I was talking about three on the side. This is where we unload the cassettes. That map on the left-hand side is an aerial overview of where the machines are placed within the factory. We do an automated recipe download on the tools, so it's consistent, repeatable. We do visual inspection on the die. The AGV is the automated guided vehicle. Goes up and driving the elevator, what's the material around the factory. The ASRS is the automated storage and retrieval system. So tape and reel, putting the reels into a box, and then those cardboard boxes get distributed to the product distribution center. Little insight into our there we go. Okay, so as far as engineering the factory of the future, you can see it's an integration of these three items. We have automation, the automation and robotics that we use to simplify the material movement, optimize the material path so that we're reducing the cycle time. Automated decision-making and reducing manual intervention. So when we have automated responses, then it's a consistent performance that we have within the factory. From an IT standpoint, making sure that we've got scalable, wireless, and readily accessible data infrastructure, because we use a lot of that data in our decision-making. And then predictive maintenance and machine learning. Kind of like your car, it needs an oil change. Well, if you were to run to fail, your tools would be going down too frequently. So what we try and do is use predictive maintenance to determine which components specifically on our tools are going to fail first, and then have preventative maintenance fixing them in advance. And then evolving to having always on facilities. Our facilities are 24/7, so they are always on. And with the use of robots, we're able to turn the lights out. So imagine the factory with the lights out, doing all the processing independently. We also leverage our industrial engineering team. They help us a lot with our digital modeling and our loading scenario simulations when we do what ifs on capacity within the factory, and then intelligent scheduling and dispatching, making sure again that the right material is moving to the right tool in the right order of priority. So that's what we mean by dispatching. So if you look at our factory of the future, it's an integration of those three things, and then of course making sure that we're environmentally responsible. I mentioned in the earlier slide that as we go through the fab, the bump, the probe, and the final assembly test process, when the material is finished, it's packaged and then it's sent to a distribution center. So I want to show you one more video on the distribution center and what that looks like. In 1 second.
I went to the whiteboard now. I want to get back to my presentation.
Oh, you want it? Okay.
With one more video. That way.
That works.
Okay, it's locked up then. One more video. No, don't restart the program. I'm trying to get to the last slide. There's one more video. And I have it also in, maybe stop sharing.
Close tabs.
Yeah. Here, and here's my auto store video.
Okay, before you should probably share with me some screen. And I'll switch over the audio for you.
Sure. Yeah, you might want to make sure that nothing pops up.
Okay, so
That's really strange. I've never seen this before.
Either.
Let's not share. Can you tell it to share one? Share
That's it.
I'll take all of it. I'll just do
Okay.
Oh my gosh.
Do you have another laptop? I could just pull up the video.
Sure.
Just open up and type in auto store.
What or what?
Auto store, STOR.
This?
Yeah.
This one?
Sure.
I'm not on Zoom so that people on like see it.
How are you connected to Zoom?
I'm not connected to Zoom. See it.
Let me see if I can do it over here. That's my computer. Get down off the screen. Have you stopped?
Okay, I can share.
To Zoom?
Run intro and I can do just.
So we've got one more video. Sorry about that. We've had some technical issues here. But here's another example of where in our product distribution center we apply robotics.
Shouldn't have to. They shouldn't need rows of shelves or long buffers. So why waste time on shelf-based solutions when auto stores here? Auto store is a cube-based system. Making use of all space for proper warehousing. Turn that wasteful liquor into storage and double, triple, or even quadruple the inventory capacity without the need for a new building. Bins are stacked right next to each other, on top of each other. Full robots drive out tracks above the queue. Those down to grab bins and deliver them to workstations. Fulfillment or replenishment. All operations get done efficiently and accurately in high-speed workstations. To get to the lower bin of the queue, the robot digs out the bin system. Every bin delivered to the workstations will be placed back on the top, making slow-running products to sink to the bottom and high runners to stay on top. With this natural sliding, digging becomes a minimum, resulting in high-speed operations. Your building can be in any shape. All we need is a flat floor. The cube can be constructed around columns and oddly shaped rooms get properly utilized. Higher performance is needed. You can add more robots. If more storage is needed, we can expand your system without stopping current operations. Easy grid construction makes expansion fast and affordable. Built for today, expand tomorrow. Auto store will never have a sick day. But if a robot gets ill, the system will continue to deliver. It is a modular system, a flexible system we can trust. 10 robots use the same energy as one battery. Save that electric bill. Auto stores being used all over the world in a great variety of industries. You have standard modules, but no standard system designs. Every system is thoroughly designed and simulated for performance and capacity before installation. Auto store can connect to all warehouse management systems and will interact with other warehouse modules. Any robot can get anything, and then you deliver to any workstation. Your goods are delivered to all of it.
Okay, so that concludes my presentation. Let me give you a little summary since we had a couple of glitches on the video side. So I started with the fact that we have a lot of internal manufacturing, as we call it, going on here, and not just in Texas, also in Utah. We've got some new factories. We've 2 in Utah, 4 in Sherman that are opening up, in addition to just down the road here in our fab in Richardson. So our front-end factories are typically here in the US, and our assembly test sites are typically in Asia. So I've taken you through the beginning to the end of the process of a wafer, and you can see from the video in the Chengdu site where we use robots and automation all throughout the process of material handling. And it really helps bring a more robust solution hand in hand with the IT piece. And then, as I said, when we're finished manufacturing at the end of the box, they go into the auto store, into those bins, and then we use that Lego, and as you heard the video say, things that are used more frequently are on top, and the things that are used less frequently are in the bottom. So that kind of shows you an application of robotics from start to end in the processing. And with that, I will conclude my speech. I want to give you some exposure to the work that you're doing and how it applies to real life. And if you have a phone or a laptop or, gaming, all of that is fed by these chips that we're making in the semiconductor. So thank you all for your time.
Now we'll be taking questions. We can start with online. So in person people, you can have any questions you want to ask potentially. So, yeah, so one question I saw a lot online was, with the auto store design, how do the robots reach the bottom bins? And the video also talks about how the more used products go to the top and the less used go to the bottom, so how does that work?
So you call. So you call for the bin and then that's what will pull it up to the top, but typically it's through the lift mechanism that takes the lower bins and brings it up to the top.
And then another question was, if everything is automated with robots, does that reduce the amount of jobs available in the factories, and is that a problem for a lot of employees?
Typically what we'll try and do is if we're starting up a factory that's going to be highly automated, then we won't hire as much manual labor. Some of our older factories are more manual, so we need more hands-on from a material movement standpoint. So instead of the robots bringing it around, it's a manual cart that we use to bring it around. But instead of resource reduction, what we try and do is repurpose. So if we've got another new factory starting up, that's going to require more resource. So we redeploy people to wherever the need is, or sometimes the job will change. So instead of moving material over here, you're going to be over here looking at charts or process controls and making a disposition on material. So we get to move around and do different things. In my 30 years, I've had 14 different jobs. So it's a case of going with the flow, finding the next opportunity and challenge, and then just moving forward. And you can leverage the knowledge that you have in other experiences.
All right, do we want to take in-person questions then? Yeah, we can type in one person question. Yes.
Just to expand on the original question of the auto store, how does the robot, if it wants the bottom box, what does it do with the box, all the boxes that are on top in order to get to that bottom?
So it has to move them. That's why keeping the most frequently turned inventory on the top is more productive. If it has to go dig deep, it takes a little longer to retrieve that. So that's why we put the older stuff.
The boxes that are on top of it, does it move it to another silo?
Yes, it moves it to a different slot.
Are we strictly open slots, or is it like stacking on top where it's gonna have to
It will relocate them somewhere else. And the bin part of it, you know, are the bins full is important because we have to have a certain amount of open slots, kind of like with, I guess, Tetris, where you're moving things around. So we want to make sure that the bins are full, and then any bins that are not completely full are consolidated so that we apply more empty bins into the system.
So how does the resupplying the bins work? Is that part also automated? You know, does the robot resupply the total into the bin?
It's a little bit of both. It's coming in. We have an inbound lane, and then we have operators that basically fill bins and make sure that we have the right capacity within the bins. So there's a manual part to the beginning to stop them all and to consolidate them. Thank you for your questions.
Yeah, thank you. So everyone, give a big round of applause.